All right. So, good morning, guys. Today we're doing calculus, and calculus is a branch of mathematics that help us with understanding how things change. It's like a super tool for studying motion, growth, and patterns. All right. And calculus in the NEC it ranges from 30 till 35 marks. All right, and there's about I would say 25 of those 35 marks that we should be able to score. Now, I'm not going to depth into what what exactly calculus is because we can go very, very far in calculus. But we're going to look for these 2 weeks up until the exam at the questions which are definitely going to be. And then, all right, so we're not going to get to optimization, and that's the last part. That is almost like I would say all of the learners can get a out of the 35 marks, all of the learners, it is possible for you to get a 30 mark. But that 5 mark question is normally an optimization question where it uses your interpretation and you need to almost interpret what is this, how does this change, and how does it affect that. But that's also an easy question. All right. On that note, I also want to apologize. I'm not a part of the bot program at all, but I do check in, and I was a part of the bot because I was a tutor at other schools, and I understand the frustration because when I walk into a bot class as a tutor, the material that you guys have is supposed to be on the table for you, all right, and that is the school's. That's the school's responsibility to make sure that the material that you are doing for that day is being supplied for you. So I apologize for that. And I apologize to the tutor as well. It is not fair towards you guys that the material is not there. No. But like I said, I'm not a part of that, but I know the frustration for you coming in on Saturday. And I will speak to the principal and also try to tell her that this is unacceptable because you guys are offering up your Saturdays and coming in, and the material is not up to standard. All right. I trust that you have had some experiences, the tutors, because if I look at the program, you've had glimpses of what the calculus entails, more or less. You have had some here and there touching on calculus. All right. So if you talk about calculus, the first question, and if we go to an NEC paper, there is going to be first principles, and they're going to ask you it in different ways. They're going to ask you determine from first principles. That is the one way. Determine from, they don't use this that often, but also when you see that question, they're going to ask you determine from foundations. That's the same way as determining from first principles. Whenever we do that, we encounter that question, Wazir, you need to go to the formula. Now let's go. What is the formula that I'm talking about? If you forget the formula in the NSC question paper, you turn to the page, and the formula looks like what? We're talking about limit. No? The derivative of f of x is equals to the limit as h approaches 0. Then we have f of x plus h minus f of x over h. That's the formula that I'm talking about. And when are we going to do this? Because when this says from first principles, from foundations, or any of those, no? But when they only ask you to determine, and they say determine or derive and stuff like that, then we can use the shortcut. No? And the shortcut is not this. All right, but be careful on the notation and how they are asking you. Then there are two ways of finding a derivative. The first way is by using the first principles, and then the other one is by using the shortcut. I normally refer to it as a shortcut because it's much, much easier. All right, but when we use not using the formula, talking about this, then you need to make sure for me three things. Now, I sent out a video last week on Friday, I think, on the group, that if you watch that video, I'm also going through that with another class. I'm talking about the first principles, and you can see how I'm doing it, and I teach it like that as well. So if you've watched that video, I am thankful for that. You will see there is three things. Who knows perhaps what is those three things? If I'm talking about the shortcut now, the shortened way, there's three things. No brackets, no surds, and no fractions, and there should be no variables in the denominators. Yeah. All right. So you said fractions, surds, and brackets. That is the three things. All right. So make sure that there isn't any of those, and we're gonna go straight to. I'm just a little bit concerned, so I'm gonna go straight. We also use now. We're going to get further as we go with this. We're going to encounter cubic functions. No, cubic is almost like quadratic, but remember, cubic is now to the nature of x to the power of 3. And the highest power of a function indicates to me the maximum amount of intercepts, of x-intercepts that we have. Like if I look at y is equals to x squared, what is the maximum amount of intercepts? 2. If I look at y is equals to x, what is the maximum amount? 1. Do you see there? So that exponent indicates to me the maximum. Maximum does mean it's not always going to be 3, but it can be less. Just like here, we can actually have 1 intercept. We can actually have here 0 intercepts as well. No? So that only indicates the maximum amount. Right. My battery is a little bit low. So I just want to go to the next page. Here's an example question of how you are supposed to do from first principles. You substitute there. No? You simplify. And these questions are nice questions. We should smile when we see these questions because this is 4 to 6 marks that we are going to score. It normally ranges from 5 marks. And today we're just going to focus on that, doing questions from first principles. All right, so let me just go on. We're going to get to the rule next. All right, so here's an exercise. Let me just go stand there still. We have already, why am I not standing still too much? Is because we have already done the notes. Now read there. Exercise says determine the derivative from first principles. And I want you to write down that question and also highlight that part. No? Determine from first principles. Now I'm going to leave that as an exercise for you to do on the board, but then I'm going to choose or make up my own one. All right? So that I want you also to take note of the mark allocation. Normally this counts up to 5 marks. Is there a freeze button on there? Is it freezed? Okay. Are we good? Yes. All right. So you can copy that exercise, and then after you've copied, you can write up until just the first line. You don't have to copy now A and B and C. I'm going to do an example first with you guys, and then we take it from there. Okay. Wil je weer inzetten? Why not?
I overslept.
What time did you close that?
8. I don't know. 8, 8.
Did you have 2 classes? Only maths.
Physics and maths.
Oh, you were at CPT. Okay, nice.
Yeah.
All you do for me now, determine exercise, practice exercise. Determine the derivative from first principles. And then you can wait for me. You don't have to copy the questions yet. But I want you to highlight for me from first principles. No? And then afterwards, I'm going to start by an example.
Damn.
Everyone has copied? No? You can just copy up until there. Alright. Okay, I don't want to do the first one. Let's just change the first one because I can't find an example now. I want to do almost like the first one, but I'm gonna change it a little bit. No? So I'm gonna say example. Example question. And let's make it, we should determine from first principles, that is the question, f of x is equals to, let's make it 5x squared plus 3x minus 18. Yeah, that is a question that can be given. This one will most probably count 6 marks. So first thing that you do, tell my learners, is go write down this formula. No? Go write down the derivative as the limit approaches h to 0 and f of x plus h minus f of x over h. After you've copied that, I want you to do, some teachers tell you to do it all underneath, no? But I've learned and I've encountered, if we go do out this part here first to the side, just like you explained in the previous video that I seen on the group, if you do that part to the side, it does a few things. It eliminates mistakes, no? Because sometimes you forget the terms and you can line up stuff so that you can see easier. So what this actually is, the top part here, is the change, is the gradient of change, how the tempo or whatever we are measuring changes. And that is what calculus is the measurement of change. All right, so we're going to do this, and then how we do this is important. So we're going to start with f of x plus h. We break this up. So we write f of x, we do this to the side, plus h, and then we, everywhere where there's x, we're going to write x plus h. So now I'm going to write 5 bracket x plus h, and that needs to be squared. Are you with me? Then, careful now, there's another x. Let's put in, I'm just going to change this quickly so that we can also make it there a little bit difficult. All right, this is a negative, no? Minus 3x plus h minus 18. Now, we are going to expand this. All right, so this becomes now, leave the 5 outside for now, a bracket squared becomes a binomial squared. So that's going to be x squared plus 2xh plus h squared. And that is now grade 11 terminology of, or basics of, a binomial square. Then we have the negative 3 we distribute, so that becomes negative 3x plus minus, you see I almost missed that. So keep your finger, left hand finger, keep it on that negative 3 and you distribute, and becomes negative 3h. That's why I included the negative now, because there is the mistakes we often make. And then minus 18. I want you to put down the pens quickly and focus here. Yeah? After this, I'm not done here. I'm going to simplify completely. So that means I get rid of all my brackets, and I'm going to say 5. Keep the 5, left hand 5 there, plain, down. 5x squared plus 10xh plus 5h squared minus 3x minus 3h minus 18. I check for like terms. There isn't any. No? Now I go and I copy f of x, which is 5x squared minus, you see where I'm writing it? And minus 18. Now I'm going to do the top part, and that is the gradient. No? So basically, I'm going to subtract this from that. And as you can see, everything lines up nice. So I call this actually the gradient of change. And that is most the sign of the gradient. So this is my average gradient. And this now becomes, you don't have to include this later the year, because they will know what is happening. The longer way of writing this is saying f of x plus h minus f of x. All right? But you can also just write there like I had m with a dash on it. So what is going to happen? This one and this one cancels out. Then what remains is 10xh plus 5h squared. That 3 cancels out, minus 3h. And then the 18, that 18 cancels out. And that is the core that we are looking for. Now you take this and you go write it on top. Yeah. It's a negative 3, no? Minus. It's a double minus and it becomes a plus. So therefore we have that. Now we take this part here. We substitute it in the numerator. So that's limit as h approaches 0. We keep on writing that, and then we say this now becomes 10xh plus 5h squared minus 3h over h. All right, let's recap. I want you to write down the steps. What is the first thing that I did? Write down the formula. No? Second step, work out what is f of x plus h. And then after I've worked out that, I've simplified. No? And then I've subtracted f of x from f of x plus h. Then that's, I'm going to do substitution back into my formula. Okay? Then, next step is to factorize out h. Factorize out h. So where can I factorize h? Yeah. So there's going to be limit as h approaches 0. We factorize out the h. What remains? 10x plus 5h minus 3 over h. Now the nice thing happens is this one and this one cancels out. And then we're going to write limit as h approaches 0. We just write everything that is in the bracket there, so that becomes 10x plus 5h minus 3. And now the limits as h approaches 0. Now, I like including this step. You don't have to. The moment when you're going to substitute this in the place of h, then you write it as 10x plus 5 times 0 minus 3. So anything times 0 equals to 0. So therefore, the derivative of this of x is equals to 10x minus 3. And there's your answer. There you have your 6 marks. All right. Quite. It doesn't have to become difficult. If you follow this, it can become long. If you do it a little bit different, if you do all of these steps, no, I can do the second one now the long way, but it's too much writing for me because you need to do the steps over and over and over again. So I prefer this way, and I want you to practice it like this as well. I have encountered that this eliminates mistakes. So I want you to make sure that you do get all of these questions right. I'm going to ask you to practice the first 3 for me. A, B, C, actually A, B, C, D, the first 4. Okay? I want you to practice that for me, doing this.